on a single blockchain. One ledger for the world. A ledger for value. A ledger for identity. A ledger for business. A ledger for honesty. Bitcoin SV, fulfilling the Satoshi vision for one world blockchain and one digital currency. One to reinvent the internet. Bitcoin SV. One world, one chain. Welcome to CoinGeek Live.
Welcome to CoinGeek Live. I'm your host, Jimmy Nguyen, founding president of Bitcoin Association, the global industry organization that advances the business of Bitcoin SV. Bitcoin SV is the only Bitcoin project and network that fulfills the original design, vision, and protocol of its creator, Satoshi Nakamoto. We are here at CoinGeek to celebrate all the advancements that have happened in the Bitcoin SV ecosystem and learn about more. We invite so many speakers today, as well as attendees from across the globe to participate and learn more about this vision, including many speakers and many of you attendees out there who work on other blockchain or digital currency projects, because we want to engage in a dialogue with the entire technology industry about the future of blockchain. We hope you learn more and learn to share our vision for why Bitcoin SV will be the one chain that can lead the world, because that's what we here at CoinGeek events really love to believe in. Over the next few days, we're going to hear from speakers across the globe who both share that vision and are learning that vision. As we kick off this conference, I want to take some time today to explain to you why we believe in the power of one. The entire blockchain industry that we have out there actually birthed from just one white paper. This, the famed Satoshi Nakamoto white paper that introduced Bitcoin in 2008 to the world as a peer-to-peer electronic cash system. It really reinvented our thinking about how internet payments could be done by reducing intermediaries and by increasing direct connection between people, persons, peers. And it also laid out the foundation for a new digital ledger technology for the future. However, Satoshi Nakamoto did not foresee a world of many competing blockchain projects and digital currencies. In fact, he saw only one. He even wrote it out loud. There's only one global chain, in this email in April of 2009 to Mike Hearn. This is a profound and critical statement. There's only one global chain. Because as we'll learn, one blockchain means more efficiency, more interoperability, more access to real-time data and the truth of transaction history. So that was the vision Satoshi laid out at the very beginning of Bitcoin's life. Here we are almost over a decade later, and that's not the truth we live in. Instead, we live in a world with over 5,000 different cryptocurrencies and probably 100 different blockchain and distributed ledger projects. How did we get here? We got here because people simply did not believe in Bitcoin and the Satoshi vision. They thought that Bitcoin should only be an asset for storing value, a digital gold, something you use to store larger amounts of value and only transact in periodically. They restricted and crippled the scale of the Bitcoin network, and that's what led to the belief that Bitcoin could only be one thing. But we believe in a much bigger vision for Bitcoin. And over the next 3 days, I'm asking all of you out there to open your mind to this much bigger vision for Bitcoin, to be not just a digital currency, but a data network, a protocol that can create the next major technology leap of our lifetime since the internet. And just like we operate on a single global internet, we believe the world should operate on one leading global blockchain. and it's only Bitcoin SV that has the power to achieve that. I want to begin our journey by taking 3 steps to educate you about the Satoshi vision for one global chain, especially for those of you who are new to the Bitcoin SV ecosystem. In addition, how scaling is necessary to achieve this vision for Bitcoin. And finally, what are the advantages for all businesses and consumers across the world? Let's begin by talking about, frankly, the important question. What is Bitcoin? It's such a simple question to some people. They think it's a new form of money, but it's so much more. Bitcoin is the fusion of data and money. And that is right there in the word itself, bit for data and coin for money. It created a system in which value could be transferred across a data network that's represented in the Bitcoin native token, but also can store and allow us to engage with data and have that data ascribed monetary value. You can do so much with this concept because data is the new commodity of our digital economy. It's the new most important commodity going forward into the future. With the Bitcoin network and Satoshi's design, we have a distributed ledger that can record payment transactions so that no one person or company is in charge of the ledger and therefore can cheat the ledger. We can all see it. It's shared and updated through a common system, and it can record payment transactions. But those payment transactions are just data, and it can do so much more. It can be the world ledger that combines data and money value. And once you understand that, you can see what you can do with the Bitcoin blockchain that combines data and money. You can write data, record data to the chain. You can read or access data from it. You can own, as a consumer, your own data, whether it be from social media applications like Facebook, your consumer health data, your consumer shopping practices. There's a way to own and also then monetize the data. And perhaps most importantly, for advanced business applications, you can compute with the data that is on-chain as well as data that's accessed from off of the chain. This opens the door to so many business and practical consumer functions: sending monetary value, transmitting and accessing data from the chain, powering smart contracts, tokenizing assets from the real world, managing all of our digital devices, powering big data, and leading to a new world of computation associated with the Bitcoin blockchain. There's so much more, even beyond that, that we can't even imagine, and bright entrepreneurs are going to develop. And it starts because Bitcoin is more than just a digital currency, and even its blockchain itself. It's also a network protocol. Just like Internet Protocol, it's the foundational rule set for an entire data network. It also provides the basis to allow people to build further systems or further protocols within or upon its rule set. For example, in the internet world, just as HTTP is a further protocol built upon TCP/IP, and it's used to transmit HTML code across the World Wide Web. Bitcoin is the major new data protocol of our lifetime since the internet. And more importantly, Satoshi Nakamoto described it as a distributed timestamp server. This is a concept that does not get enough attention, but we'll discuss during a dialogue I have with Dr. Craig Wright during tomorrow's sessions at this conference. Satoshi described a system where you could timestamp transactions or business events in history across chronological order. Instead of one person or a company keeping that timestamp server, it's distributed to prevent cheating. By having a distributed timestamp server, we get a chronological history of events. And that makes the Bitcoin blockchain an auditable, verifiable, and transparent distributed timestamp server, because the ledger is public. That doesn't mean all the data on the network is publicly accessible. It can be encrypted or obfuscated to protect privacy. But the ability to check that certain transactions or events in business and history happened at a particular moment in time is time-stamped into an ongoing chronology, an ongoing ledger. And that provides immense business power. In fact, it opens the door to what we believe are the key aspects of a true blockchain: that it's public, a public global distribution of data. It's transparent and audible so that people can access and trust the chronology of events that happen on it. It's immutable, difficult, if not impossible, to change and tamper with. fast and low cost, so you can have huge volumes of payments and other types of business and data events recorded to this chain. And it has privacy, yet with traceability to deter bad behavior. The true blockchain can deliver this and Satoshi's other big theme in the white paper, honesty. The word honest is used 15 times in the white paper because Satoshi wanted to create an honest system. And by having this big, open, public ledger with the chronological, time-stamped history of events, we can create a society where business activities, our consumer engagements are more honest because they can be proven to be right or wrong, traced across history. And that is why the Bitcoin SV node, and now known as infrastructure team, restored most of the original Bitcoin protocol. It always had these capabilities, as well as technical functions that could do more advanced features. But they were restricted, limited across the journey of Bitcoin's life on the BTC network. So in February of this year, our technical team restored most of that protocol in what was called the Genesis upgrade to unleash the power of the dragon, the Bitcoin SV node symbol, into now Bitcoin SV as the protocol data network for the future. We are going to continue that journey by now explaining to you why it's important that Bitcoin needs to scale. If you've got this great protocol with all of these technical powers, how does it become the one chain for the world? The answer is simple. You got to scale, and you've got to scale big. In fact, Satoshi Nakamoto said this himself in that very same email to Mike Hearn, in which he said there's only one global chain. Way back in 2009, Satoshi said that the existing Visa credit card network processes about 15 million internet purchases per day worldwide. Bitcoin can already scale much larger than that with existing hardware for a fraction of the cost. It never really hits a scale ceiling. Satoshi knew back in 2009, Bitcoin was never meant to hit a scale ceiling. It was meant to scale big, to be the one global chain. But that's not what happened, because the BTC network chose, for various reasons, to restrict its block size to a small amount, 1 or 2 megabytes, and thus its transaction capacity to about 7 transactions a second, nowhere near the levels of the Visa network, which just 2 to 56,000 transactions a second. It would be like creating the early days of the internet and email and saying, you know what, we want to limit the number of emails that can be sent per second or per minute to 7 seconds or 7 emails per second across the entire world. If that had happened, email would never have grown into the very powerful usage it has for life in consumer and business worlds today. Bitcoin SV's vision is very simple: unbounded scaling, because that's what Satoshi's vision always contemplated. It means that there is no preset limit on the scaling capacity of the Bitcoin network and BSV. Instead, it's up to market forces to let the volume of transactions, the block size, the throughput capacity grow as much as is necessary to sustain what is needed on the network. It means we can also avoid the problems hitting the Ethereum network since well over a year ago, in which the blockchain was reported to be almost full. They needed to launch Ethereum 2.0, and because of the DeFi craze that's happening now and a lot of buying volume, Ethereum gas and transaction fees are hitting a record high. That is not a good thing. Over the past few months, I've seen Ethereum gas fees hit $14, for example, per transaction. You cannot have a business network with tokens and smart contracts executing at scale for any meaningful business if it costs that much to send a transaction. Well, what is Bitcoin SV's path? Here's a chart that helps explain where we are in the growth of our network. Currently, Bitcoin SV is comfortably doing over 2,800 transactions per second on our main network, well above BTC, Bitcoin Cash, Ripple, even Hyperledger. Nowhere near as it takes to rival the Visa network. But by next year, our technical team thinks that with continued technical upgrades and improvements and performance, we will hit 50,000 transactions per second on our main net and continue to grow from there. In fact, our scaling test network, in which we're testing some of these improvements, has been mining blocks that contain individually anywhere from 2.7 to 6 million and even 13 million transactions per block, creating theoretical throughput of 64 to 6,500 transactions per second. And we want to go massive. The nChain team is working on what's called Terranode, an enterprise-class version of the Bitcoin software designed to sustain in the future terabyte-sized blocks. That's 1 million megabytes, where we think you can do 4.2 million plus transactions per second. And that means a data network that can power not just payments, but all forms of data for the entire world. It also means we can do it for very, very low fees. No Ethereum high gas fees. Currently on the Bitcoin SV network, just this past weekend I checked, our median transaction fee on the network was well less than 1/100th of a US cent. And over time, we think that number's too high. It needs to get smaller and smaller, and it will. And that means we opened a world of micro payments and microtransactions, where you're sending across the internet and digital devices not $100 or $50, but 1 cent, half a cent, 5 cents, a quarter cent. And that means all forms of our online activity and data can be monetized. Imagine a world, for example, where you actually pay to run an internet search, but the search results you get are better because there's no sponsored ads or sponsored links to go through. Imagine a world where your consumer data is owned by you on the blockchain and someone can pay you 5 cents, 2 cents to access it if you so authorize. Over the next 3 days, you'll see so many use cases for this emerging across Bitcoin SV. On the screen, you'll see some of those example areas: healthcare data, clinical research data, supply chain management, esports and online games, casino and iGaming tech, social media, entertainment and media content, identity management, big data feeds, IoT, digital advertising, the AR, VR and experiential reality space, financial the world cannot have their own coins and assets, but it means there can be one base ledger that powers them all, creating greater efficiency, avoiding the issues of interoperability, and providing consistency, just like we have one global internet. We can also break down data silos. You'll hear about this a lot over the next few days. It is a powerful, powerful impact of one global chain, especially if it's public. In too many of our industry sectors, we have data that's kept separate. The US healthcare industry sees this, where my doctor's data for me is different than my dentist, different from a specialist surgeon, it's different from the pharmacy where I get my prescriptions filled. In supply chain management and logistics, across the travel of product across a supply chain, data is kept in different places by different organizations. It makes it hard to access real-time information, which we need to make better business or even healthcare decisions by your medical providers when they're prescribing you drugs or other treatment. Having real-time access to all available data across the value chain of an industry brings not just greater efficiency, but much more powerful decision-making for us as consumers and businesses. And that's also especially important because we can get that data in real time. No waiting to sync and making sure you have data from the correct databases across the world or across steps in the industry value chain. Real-time access means real-time better decision-making from a public chain where the data still can be protected in terms of its privacy with encryption and obfuscation tactics for the data, but it provides the ability for anyone across the world to access the transaction history in real time. That leads to improving product and asset traceability, whether it be physical goods we ship, intangible assets, our very rights that can be tracked on a chain, such as intellectual property rights, voting rights. It improves the traceability in a way that brings more honesty, more efficiency, and more transparency to the world. It's also great for satisfying auditors and governments. A lot of people in the digital currency world don't like to engage with the governments of the world. They want to be anti-government. Bitcoin SV's ecosystem is absolutely the opposite. We believe to achieve global adoption, this technology needs to integrate and win the confidence of government agencies across the world. And wouldn't it be easier if transactions are recorded on a publicly accessible chain that auditors could be tracking on a daily, monthly, quarterly basis as opposed to doing it at the end of the year? Wouldn't it be easier for companies to report to their government agencies that regulate them, such as in the gaming industry, reporting to a gaming commission, their revenue and transaction history that could be trusted from a public chain rather than having questions from regulators about whether the data is accurate? This is a powerful use case for blockchain technology, and it leads to this final one, which we'll hear so much about over the next few days, reinventing the internet. That's what Satoshi envisioned. Go back and read that white paper. It talks about transforming and making more efficient the ability to send payments on the internet. You'll hear from companies that want to change how social media performs, how consumer reviews perform, how digital advertising performs, because consumers can own their own data on the blockchain and can monetize it with small amounts of micropayments and change all online and digital activity as we know it. It's such a powerful vision, and I hope that you'll see it changes the world where everything can be online to a world where everything can also, if you want it to be on-chain, with two layers interacting, data on the blockchain monetized with the online internet and the activities and applications we enjoy and love every day, working together to be better with one. If you like this vision, I ask you to join us. Visit the Bitcoin Association website at bitcoinassociation.net. And you can apply to become a member or affiliate of our organization. We have members across the globe, across the ecosystem set of participants, miners, exchanges, wallets, enterprises, startup developers, as well as many other service providers. It's a big group because it will take all of us to help fulfill this Satoshi vision. We're also doing it from our new headquarters in Zug, Switzerland, the crypto valley of the world, as they like to call it. Switzerland is a global capital for finance, business, technology, and now digital currency. And from this one headquarters, we are reaching out with teams across the world to advance the business of Bitcoin SV and the vision of Satoshi Nakamoto. I hope you see this bigger vision. It's so big. It's a vision for one. A vision for one world that is more connected. A vision for one data network that breaks down walls and builds bridges. A vision for one Bitcoin that unites the far reaches of our globe. A vision for one system that helps us reach out to people, peer to peer, connecting us across a universe of constant digital interactions. Bitcoin was introduced as a peer-to-peer electronic cash system to reinvent how internet payments are done by using a distributed record of transactions. Transactions organized into blocks, connected over time. But those blocks can contain more than just payments. They can contain the one most powerful commodity of our digital world, data. Therein lies Bitcoin's bigger vision, the fusion of data and money to connect everything in one digital currency that transcends geographic boundaries, one protocol for a data network that powers enterprise applications, one universal source of truth that breaks down data silos and opens data transparency, one ledger that traces products, assets, our rights, and the very sustainability of our planet. Many names: distributed timestamp server, time chain, blockchain. But no matter what you call it, it is more effective, more powerful, and more connected if, in the words of Satoshi Nakamoto himself, there is only one global chain. One chain connecting everything, everyone. Whether you're from Vietnam, China, Australia, South Africa, Argentina, London, or here, New York City. Bitcoin SV, one world, one chain. We are indeed one world, living through unprecedented times. And that's why we could not gather you all here in person in New York for CoinGeek New York as we had originally hoped. But instead, we've pivoted to this virtual conference for the next 3 days. I want to thank our amazing event team and the production teams here in New York City, as well as in a second broadcast site that we're syncing to live in London. We'll be bringing you speakers from our site here in New York, London, and remotely from across the world. And it is really reflective of our times that we are connecting the world in this way, as we also hope to connect the world with one blockchain. The vision I just laid out is very grand. We know that. It will take a lot of technical achievement to get there. Helping lead the way in that technical achievement is the technical director of the Bitcoin SV node, and now known as Bitcoin SV infrastructure team. He's also the chief technology officer of nChain, a leading global blockchain research, development, and advisory business with a research facility and development arm based in London. He is a key voice and figure in what makes Bitcoin SV work. He'll be here today to talk about releases that just happened today to the ecosystem, and the peer-to-peer vision of Bitcoin that Satoshi laid out, and how that is necessary to achieve this big scale. Please welcome to the London stage my colleague, my partner in the Bitcoin vision, and my friend, Steve Shatters.
Thank you, Jimmy. Today I would like to reveal to you some of the key missing pieces, in fact, what I believe might be the last missing pieces to truly realize the peer-to-peer vision that was laid out by Satoshi Nakamoto in his 2008 white paper. It's very difficult to talk about Bitcoin without using the word peer. It's right there in the title of the white paper. But what is a peer? This is a word that I think has been used and occasionally misused in the history of Bitcoin. It's often used to refer to a node. But the Bitcoin network, in fact, has more than one type of peer. And the definition of a peer or a peer group rather, is a group of people that share some kind of commonality in either status or capability. And in fact, Bitcoin has more than one type of peer. Let me read you a piece of the white paper, a purely peer-to-peer version of electronic cash. It's fairly clear. It's the third word of the white paper. Would allow online payments to be sent directly from one party to another. Here in the second phrase of the first sentence of the white paper, Satoshi Nakamoto is describing the most important type of peer in the Bitcoin network without going through a financial institution. The alternative to a financial institution in the Bitcoin world is, of course, the miners, the nodes. And these are the types of peers that people most frequently are referring to when they use the word peer. But let's jump back to this middle one, because what this is actually describing is the users of the Bitcoin network, not the miners, arguably the most important kind of peer in all of Bitcoin. Because without users, what is the purpose of Bitcoin? Why do we need miners? Why do we need Bitcoin at all? Satoshi clearly understood this, because in the very first edition, the very first version of the Bitcoin software that was released, it contained a feature which these days we call IP-to-IP transactions. Back then it was often referred to as IP transactions. And it was simply a mechanism that allowed one user to connect to another and exchange transactions between them in a peer-to-peer fashion. It embodied the way that users are supposed to deal with the Bitcoin network, but it was incomplete at the time. Bitcoin is supposed to scale, and one of the primary principles of scale, it's so simple that it almost doesn't need stating, is don't do work that you don't need to do. And of course, when users have to listen to everything that's happening on the Bitcoin network, when they have to listen to details of transactions that are happening on the other side of the planet that don't concern them at all, that's one of the first barriers to scaling. And it was never part of the original Bitcoin design. The first version of Bitcoin, of course, incorporated a wallet. It incorporated all of the logic required for mining, but it was intended as an alpha version. It was a proof of concept. It also included IP transactions. And I firmly believe that Satoshi intended the client side and the mining side of Bitcoin software to diverge fairly quickly. So we didn't quite get there at the time because of some technical limitations and because of the fact that the IP transactions implementation itself was a prototype. It was a proof of concept. It was something that Satoshi network, users of the network can actually interact in the way that your IP address and post it in a forum, the Bitcoin Talk forum. More specifically. Now that worked, but of course, posting it on a forum isn't exactly a user-friendly or scalable experience. And then there's the problem of how to connect. This is a common problem. It's not Bitcoin specific at all, but the way that the internet is fundamentally designed is in this kind of a request-response manner. When you as a user want to make use of the internet or a website, etc., you make requests outbound. And Bitcoin, typical internet routers, the type that you have at home that connect you to your ADSL or your fiber connection, etc., mostly have firewalls that allow connections to go outwards, but they don't allow them to come inwards. And that works fine in the web model because that's just how you use the web. You request resources. But when you want to talk peer-to-peer, this presents a problem. And like I said, it's a well-known problem. There are many applications on the internet that have to find ways around this. So it doesn't matter which direction you're trying to go. There are ways around this, including network address translation. None of them are particularly simple, though. And none of them are well adopted. Then, of course, there's a problem of how much your transaction is going to cost. This problem remains unsolved for BTC today. You have to guess. You can't even ask a miner. But even if you could, the answer they gave you may not actually be accurate. They themselves don't know. Because at the moment you send a Bitcoin transaction isn't the moment when a miner actually makes the final decision about whether to include it in a block on BTC. The price that you pay or the price that is required may well change between now and when the block is mined. So we've got that question, and then of course there needs to be an interaction between the two parties who want to transact with each other. This comes down to the communication problem, but also how to structure those communications. So how does a merchant tell a customer how much they need to pay? Then there is the problem of how we'll get our transaction confirmed. On the Bitcoin network, traditionally the way we've done it is spit it out onto the peer-to-peer network, and then some magic happens, but we don't really have any visibility of that. We can't see if something has gone wrong because there's no feedback loop between the users and the miners. And of course, the most critical part of the peer-to-peer vision was the simplified payment verification technique that was described in Section 8 of the Bitcoin white paper. It requires a thing called an SPV proof, which is a thing that the miner has to give back to the user once the transaction has been mined into a block. But there's never been a mechanism to do that, and certainly not a reliable one. And then, of course, comes a further problem. When we send the transaction, of course, by definition, we have to be online, but the Merkle proof, the SPV proof, doesn't come back to us until much later, and there's no guarantee that we are still online. So how do we get these messages? Peer-to-peer transactions are the missing piece of the configuration, I suppose, of the Bitcoin network. And we've solved some of these problems, but not all of them. But collectively together, the set of tools that you actually see on the screen right now, Paymail Miner ID, Bitcoin D, BIP270, MAPI, and a new thing called SPV channels, can solve all of these problems for us and provide a complete end-to-end solution to implementing the peer-to-peer interaction that the white paper describes. So put them all together and you have peer-to-peer. So I would like to announce the release of 3 new products today. 2 of them are updates to ones that you're probably very well familiar with. And one of them, of course, is brand new, SPV channels. So these are all beta. We wanted to get them out because we want developers to be able to start playing with them, start experimenting and start attempting to implement this end-to-end interaction. So Bitcoin SV 1.06 Push Edition contains new functions to provide and verify Merkle proofs. The Bitcoin software hasn't been able to do this until now. It now provides 0MQ notifications when double spends are detected. And the part that is still work in progress, which will be in the final 1.06 release, is a new peer-to-peer message that allows miners who detect a double spend to broadcast the fact that that double spend exists across the network in a provable way. This is very important because the way Bitcoin works right now, the way the software works, is when a double spend is detected, the node that detects it simply suppresses it, drops it, ignores it, it doesn't tell anybody. And that may be okay in some cases, but if a merchant is looking for confidence that a transaction submitted to the Bitcoin network will either be confirmed or that they'll know that it's not going to be confirmed quickly, then we need these double spend attempts to be broadcast and well known to the entire network. The merchant API leverages the new SPV, the Merkle proof capabilities, and adds to it by moving from a request response model to a model that many JavaScript developers will be familiar with, an event notification model. So when you submit transactions to the merchant API, you can register for callbacks on events relating to that transaction. And the two that we have implemented now would be double spends or when the transaction is mined into a block. But other events could easily be, we could easily extend this to include other events, such as when the outputs of a transaction get spent. And finally, SPV channels. This is an end-to-end encrypted messaging service with a push capability that provides an always-on point of presence for a Bitcoin user and provides a single unified interface for handling the receipt of messages, whether you're online and offline. And what it does is it provides you the best user experience that is possible, taking into account your online, offline status. SPV channels is not a very Bitcoin-y thing. It solves a problem that's actually a problem that is encountered outside of the Bitcoin world quite commonly. But think of it as something like an email server, an IMAP server. It's intended to be a hosted service, which means someone has to pay for it. And in fact, it may well become the first example of a nano service taking advantage of the nano payments capability that was put into Bitcoin SV 1.05. Because it's intended to be a hosted service, of course, end-to-end encryption by default had to be a part of the picture. In addition to this, today we're releasing a new version of the Bitcoin SV.io website to reflect the fact that it is no longer just a home for the Bitcoin SV node software. It is a home for a suite of products which we classify, I suppose, under the banner of Bitcoin SV infrastructure. So go take a look at the site. It's got links and information about all of the 6 services that I just described. So how does all this work together? Well, we walked through the process just before and we discovered the problems. So let's go through it again and talk about what the solutions are. The first one, how do I locate my transacting party? Well, this is what Paymail was originally designed for. It's intended as a service discovery mechanism. We've only implemented one way of using it so far, but there are many others planned and in the pipeline. And it replaced the need for users to swap Bitcoin addresses in order to be able to pay each other. Replaced it with a more generic and much more flexible model of simply passing output scripts, which means any complex script is now easy to pay to. And of course, SPV channels comes into the picture here because the service discovery mechanism for an SPV channel, or one of, the way that we've done it, is Paymail. If you know an SPV user, a Paymail user's Paymail address, then you can find out where you can contact them with an SPV channel. So a quick demonstration of how it works. It really is quite simple. You can see down the bottom, we have the channel server that belongs to the character here on the right, the blue guy. And over on the left, let's call her Alice. She has her channel server at the top. So both of them, note, are going to make outbound connections to the channel servers. So they get past their ISP routers, their firewalls, simply by both making outbound connections and making use of an intermediary. Messages are either stored or forwarded, and it simply depends on whether the recipient is online or not. And channel server knows whether there's an active the address of which is either contained in the original message or can be resolved using Paymail. So very similar model to the way that, that email works. With an IMAP server, it's also got that same push capability. So how does it work beyond the prototype? So here again, we've got a slightly more detailed version of it, which actually includes the routers, and you can see the flow of a message that goes all the way around in a circle. But what does it look like to a user? This is the important part. Once you abstract Skype, Zoom, TeamViewer, these are all things that require direct connections between two machines that are probably behind firewalls. And the solution is largely the same. Whether they're end-to-end encryption is, the degree of end-to-end encryption, I suppose, is a variable, but we've baked that in from day one. So this is what it looks like from an end user's perspective. It's a virtual channel. From their point of view, if both users are online, messages pass straight through. It's almost like they have a direct connection to each other, with the added advantage that if you're sending a one-shot message to someone, you don't need to care whether they're online or not. So now that we've solved that problem, how much will it cost? Who's going to mine my transaction in the first place? Well, we've got Miner ID for that. Miners can use Miner ID not only to take ownership of their own mining history, but also as a service advertising mechanism. So we query Miner ID, we find out, we want to know what fee is required for a particular quote. So now I, as a merchant, know exactly what is required from this transaction. I may also want to, I now want to create a transaction specification for the end user, so the user knows exactly what they have to do to create the transaction to, in order to complete the purchase. And so we have BIP 270, or possible future variants of BIP 270, which describes how that transaction specification is structured. And it may include more things than just what transaction fee you need to include and how much you need to pay. It may also include a request to include nano payments for other services that are required as part of the transaction. I may be subscribing, and in this case I am subscribing for an event notification on the transaction to say, can you tell me if it's double spent, or can you tell me if when it's mined, and give me a Merkle proof. We could piggyback off this existing transaction to pay for those nano services. So, and now how do we submit the transaction? Well, the user, the customer, sends the transaction to the merchant, who's the one that cares about getting it confirmed, and the merchant takes responsibility for getting it to the miners. Because we have miner discovery and merchant APIs, they can contact them directly. They can get a response from the miner immediately as to the status of the transaction. How do we get a security proof? The SPV proof, the Merkle proof, lots of different names for the same thing. Well, when a block gets mined, Bitcoin will notify Merchant API of it. Merchant API can now go and request all of these Merkle proofs that it's been asked for. And using an SPV channel, the address of which was given when the transaction was first submitted to the miner, they can send back the Merkle proof. And the user now knows everything is okay. Optionally, merchant can also send a copy of it back to the user, because they will probably care, because they've got change addresses being spent. So they may be receiving change as part of that transaction. And so in the offline use case, the user has gone offline or the merchant has gone offline. This is just a quick demonstration of what happens. The messages just queue up. There's no magic here. It's just an implementation of a solution to a well-known problem. User comes online, of course, and it's just like downloading all your email. So, I'm going to pray for the demo gods to be kind to me today. We have built a demonstration of all of this, and behind this we've got a Bitcoin node and a reg test stack, a merchant API, and an SPV channel server. And what we have here at the front end is a basic wallet for a customer and a merchant. And to begin with, the merchant is actually connected to their SPV channel. They're requesting push messages. So let's just send a message into that channel. And you can see what's happened here. They've grabbed it. They've received it immediately. Let's disconnect the merchant now. To simulate him going into the subway or somewhere where he's got no signal. Send the message, nothing's come through. As soon as the merchant comes back online, bingo, we have our message. So you can see that the use cases for an SPV channel go well beyond Bitcoin. I imagine people will come up with all sorts of interesting ways to make use of it. But let's just look how it works in Bitcoin. And first we'll start with the simple case. The most likely case where everything goes well. Customer pays the merchant because they've already received the transaction spec, and you can see we've sent it to the merchant. Merchant receives it. They do what they need to do next, which is submit it to the merchant API. And in this case, the merchant API responds with success. Well, that's great. We know that this transaction is going to be accepted by this miner. If we contact every miner, then we can probably get pretty close to perfect assurance that it's going to get mined. So some time goes by, and eventually a block gets mined. And then what happens? The Bitcoin node contacts the merchant API to say a block has been mined, and the merchant API retrieves the Merkle proofs and sends them out to the various users. In this particular case, I've done a couple of transactions before, and we've got a slight bug because we're repeating them twice. But here you can see this is the Merkle proof data structure itself. And it's been received by the miner because they happen to be online. So let's just try another scenario, a double spend. This is an accidental double spend, and you've always been able to detect it when it happens this way around. We've actually created the double spend and sent it out first. And now, whether by accident or by intention, we try to spend the same coin a second time. So what happens? Well, we send it to the merchant, and the merchant submits it to MAPI, which immediately tells us that we can't spend this transaction because we're missing inputs, which is another way of saying it's double spent. So that part isn't really new. What's new here is another double spend scenario that we haven't actually been able to deal with in the past with previous incarnations of the software. So here we've just sent the transaction and everything has gone smoothly. That's fine. And then we walk out of the shop and we send the double spend transaction. What would normally happen is this transaction would go hit one node on the network, which would recognize it as a double spend and then drop it, and no one would ever hear about it. But we need to do better than that. In this particular case, the node actually hears about it. It tells the other nodes that it knows that it's connected to that there is a double spend. And when it reaches the node that actually has the event notification registered for the double spent transaction, it will immediately use SPV channels to notify the merchant that a double spend has happened. And this is almost as good as stopping it from happening at all in the first place. Because the merchant can take action. They can say, okay, well, this transaction you've given me, this banknote you've given me is counterfeit. I'm not going to accept it. And so is this transaction. So the demo gods have been relatively kind to me today and let us get through most of this without crashing. And a big thank you to the nChain team. We worked very hard to actually put this together in a very, very short time frame. I hope what we've demonstrated here today will serve to help people start to implement the Satoshi vision, the peer-to-peer client-side part of Bitcoin, which is so important and has been so neglected for the last 11 years. This is not the only way to solve these problems. It's one way, but it is a complete end-to-end solution to the Bitcoin user experience. Thank you.